I skipped a couple examples just because of time constraints, and I wanted to finish up by talking about the amortization formula because there will be one of these on the exam. But the amortization formula is a formulaic solution to the question, if I have a loan and I want to make a monthly payment every month for a certain time period, how long would it take me to pay that off to counteract the interest that's accruing compounded monthly? Now, usually you can adjust this formula to have other periods of compounding, but how it's presented is to deal with accounts that are compounded monthly. And the reason that's the case is because almost all loans, like mortgages or credit cards or whatever, are done on a month-by-month basis. That's the most common form of financial transaction. And let's just go ahead and look into it. So the amortization formula, in some classes we'd actually derive why it's true, but we don't have time for that here. Let's just kind of practice using it and figuring out how to apply the information. But basically in the formula M, it's solved for what monthly payment would I need to pay it off on time, assuming that the principal value of the loan is P, how much you borrowed or lent, whatever the case may be, but how much was borrowed initially. M stands for the monthly interest rate. Sometimes it's called the periodic interest rate, but basically it's just the APR divided by 12. R stands for the interest, using the same variables that we had from class time for the compound interest formula. In other words, what's the interest rate divided by 12? That will give you your monthly interest rate. And lastly, capital T stands for the number of installments, which basically you're going to be paying it off month by month by month by month over a period of some number of years. It's over that period of time, the number of installments is how many payments did you make, which is just going to be the number of years, T, remember T stands for the time frame of the loan, multiplied by 12, because T is almost always in years. And so this multiplying by 12 will give you how many months you have in the life of the loan. So let's look at an example. Suppose you have a student loan balance of $50,000, which is undergoing interest at APR of 7.2% compounded monthly. I tried to create a fairly realistic situation for a student in debt. Let's say that you're on the 20-year plan to pay back the loan. We want to know how much are we going to be paying month by month in order to pay the loan off. And student loans have some other things. Usually, there's a period before they start generating interest when you graduate, and there's other rules, like it shouldn't be generating interest right now while you're in school, but as soon as you are done and and the grace period is up, it will start generating interest, and you do need to start making payments on it. And also the interest rate of 7.2% is fairly realistic, and I think it's criminally high for students to have to pay such a high interest rate for school, but they are risky investments, so because not all students are actually able to pay them off. I'm not trying to scare you guys or anything, but it's just, it's a thing. Anyways, one of the reasons I like to go into this math is because I feel like a lot of people have fear about their debt or about their loans. And at least in my opinion, the fear of it is kind of due to lack of understanding. Like, how is this, like, understanding the mathematical process of how it's going helps me feel a little bit more at ease about what I'm getting into. And at the end of the day, one of the key problems with a lot of people in their finances is lack of understanding, or buying things you can't afford. Anyways, let's just use the formula to figure out how much our monthly payment will be. But basically, it might be nice to figure out, well, what's our monthly interest rate? That's our annual percentage rate divided by 12. Here our APR, or annual percentage rate, is 7.2%. Again, in mathematical formulas, we want to plug that in as a decimal, so 0.072, and dividing by 12 will help me figure out what that is as a monthly interest rate. So that would amount to be 0.006 or 0.6%, meaning every month it's going to grow by that. Doesn't seem like a lot, but again, it adds up, especially as compounding occurs. And then the principal is the starting value of the loan. So the monthly payments will be equal to the principal value, capital P, times the monthly interest rate. And if you're wondering, well, where did this formula come from? why is this make any sort of sense? That is not, it's not a hard question to answer, but it involves some mathematics and some derivation, stuff that we are not needing to cover. We don't have time to cover in this class, but it's still, I think it's a good thing to know and to understand at least how to find the answers. And then notice in the parentheses we have 1 plus m, or 1 plus 0.006. That'd be 1.006 raised to the t power. Now, another thing I have not figured out is what is capital T? That's always 12 times little t. Little t is our time frame, and since our desired payback time is 20 years, it would be 20 years for t, and 20 times 12 would be 240. So that just means I'm going to have 240 payments to go to pay off the loan, capital T. And then the denominator, it's actually almost exactly the same thing, 1.006 to the t, 1 plus m minus 1. And this formula is actually remarkably simple. It involves some, usually I would do this in a Calc 2 course, talk about why this makes sense, but for our purposes, there we go. So let's just throw it in the calculator and see what we get. Also, as I've said before, be careful with rounding your periodic interest rate. A lot of times you're going to get decimals that are infinitely repeating. I would use at least 3 to 4 significant digits. Like here, it just happened to be 1 sig fig 6, 0.006. And so, but if it is more, if it does involve more digits, make sure you use more than just 1, because rounding error will compound, especially in this formula. When you're exponentiating to the 240 power, it will be very, very off if you round that. So I would, use as many decimals as you can. And I'm making sure to use parentheses around the denominator. Actually, I missed the front one to make sure that I'm dividing by all that. So make sure, you can put parentheses around the top and the bottom just to make sure. But what I get here is a monthly payment of approximately $393.67. Often we would round that up, because if we round it down, this exact amount is the amount we need to pay it off. And if we're a little short, we'll be a few cents off. But at the end of the day, it doesn't really matter. I will round it up just for the reasons stated. But if you just round it conventionally, it's not a big deal. It's like 1 cent. And yeah, so if we make this payment every single month for 20 years, our loan will be paid off. Now, another question we could ask is, over the life of the loan, what is the implications about how much we've paid and how much will have been interest? But one of the reasons I think it's good to go through this is what are we actually paying for this loan? Because obviously we're going to be paying back to $50,000, but how much interest is actually accrued over the period of those 20 years? And I think, as I said in class, like the longer it is, the more time interest is accrued. It's probably going to be a lot. And a lot of times it's actually way more than you would expect if you haven't really looked into the math of, the amortization formula before. But basically the total paid, I'll just write that out, total paid is going to be equal, it's always equal to the number of installments times the monthly payment, MT. That's just because this is how much I'm paying every month. This is how many installments I pay. So multiplying the number of installments by the installment amount will give you how much you're paying over the course of those 20 years. So 393.68 times 240 installments will be a total paid of $94,483.20, which is a lot. And of course, taking the difference between that and then subtracting off the principal, $50,000, would leave me with $44,483.20. And this would be how much interest we paid for the luxury of having a loan. Which, again, if you haven't seen, a lot of times when I'm in class, I get a reaction to this, which is like extreme amazement, or it's a staggering amount, but you're paying almost double what we borrowed in order for this loan to happen. And the reason why I get into this is not to scare you, but the fact that this was such a long loan implied that there was such a long time for interest to accrue. Even though we're paying it off, it's still growing very, very rapidly. And it's growing faster at the beginning than it is at the end. You can actually look at the derivatives of these things, which we don't want to do because, again, looking at the complexity of these formulas. But anyways, it's a lot. And so another thing is, when you're looking at your loans, another thing that I think is worth it to bring up is that the plan makes a big difference. Like if you change it to a 5-year plan or a 10-year plan, your monthly payment will actually go up quite a bit because you're paying it off faster, meaning you have to pay it off in 5 or 10 years. And it can seem like a worse deal without looking into it. But just given the fact that you are paying it off faster means there's way less interest. So it is better. You want to pay it off faster if you can. So obviously, let's say we change it to a 5-year plan. Our monthly payment might be, I don't know, $800. I'm just making up a number, but that we might not be able to afford it. So the flexibility of the plan that you use can be dependent on what you can afford. But obviously our goal is to pay it off as quickly as possible. And also another just general principle about loans is you can pay them off early. You don't have to pay off just the monthly payment. You should pay off more if you can afford to, because otherwise you're just letting interest accrue that you could have canceled out. And that's the general principle of debt. Pay it off as soon as you can and don't get into debt unless you absolutely need to. Another perception about rich people versus poor people is you tend to think that people who have a lot of nice stuff are richer than people that don't. But a lot of times it's exactly the opposite because, if someone's very rich, they can afford to buy things without having loans. But some people will get themselves into debt by buying things they don't have the money for to try and make it look like they're wealthier than they are. And you're actually really hurting your wealth by buying things you can't afford, getting credit card or debt or whatever. Student loan debt is a different situation because you're investing in your education, in your future, and that's obviously different than just buying a fancy car that you can't afford. But anyways, and people that often do not look wealthy, that don't drive fancy cars or have ridiculous houses, often are probably more financially secure because they're probably saving their money instead of spending it on things. Again, a huge part of the equation is how much is your income in all of that, but even people that don't have high incomes can save money, become wealthy over time just by not spending it, obviously. Anyways, that'll wrap up this chapter.